JMath.
Welcome to a video on interpreting cubic graphs. So like I said in a previous video, there's three questions that you're going to see in an exam relating to calculus. The first one, first principles and the rules of differentiation. The second one is graphs, where you're either going to have to draw something or where they drew it for you and you need to interpret the question. That's what we're looking at now. The third calculus question is word sums. So we'll get to that in a later video on this playlist. But for now, let's focus on interpreting graphs. Now, out of all the sections, this is the one that counts the most, and it's split up into the most type of questions. So I'm going to attempt to show you some of the questions that's asked almost every time. So let's go. Intercepts. So to get a y-intercept and to get an x-intercept. You learned this from grade 9 when you started drawing straight lines. And it's still the same thing. So if you want a y-intercept, you make x equal to 0. If you want an x-intercept, you make y equal to 0. And then you do algebra and solve your equation. To get distances, they love asking, what's the distance between AB or between BC? So let's just look at this quickly. So if it's a vertical distance, AB, then I would just take the top y value minus the bottom y value. So this answer would be 5 minus 1. And therefore, AB will be equal to 4 units. Okay, so remember to please put a units next to it. If they give you centimeters or meters, write that. Otherwise, write units. So if it's two dots that directly above one another, then it is the top one minus the bottom one. If it is a horizontal distance, so BC, I would say BC is equal to the right x value minus the left x value. So 4 minus 1, and that would equal 3 units. Always the bigger one minus the smallest one. If they ask you for the distance of AC, you would just go with your analytical formulas and just use the distance formula to work out AC, or you can do Pythagoras if there's a 90-degree triangle. You must just check in your exam exactly what info you have and then choose the correct way. But the safest one is to just use the distance formula, even if it's horizontal and vertical, if you are unsure. Now, to get a turning point, you would always use the first derivative and make that equal to 0, and then solve for x. Sometimes you'll get one answer, sometimes you will get two answers. But check then, do they just want x or do they want the coordinate? If they want the coordinate, sub that x value into the original fx to get y. Okay, the point of inflection is the double derivative equal to 0. Then you solve for x, sub that into the original again to get y. Please always remember, if I need a y value, it's always going to be connected to the original fx. Then questions that's almost there in every single paper, they're going to ask you where is the graph increasing and where is the graph decreasing. Okay, so in grade 9, you learned that when a straight line goes from the bottom left to the top right, then it is an increasing line. And if it goes top left to bottom right, then it is a decreasing line. That still applies with these questions. So if they ask me with this graph, where is it increasing? Okay, so the top one would increase for all x values less than the first turning point. So my answer I would write as x is smaller than 2. Or x is greater than 4, because there it increases again. Okay, if my graph looks like the bottom one, I need to say it's increasing when x lies between a and b. So I'll say when x is between 2 and 4, it's increasing. Okay, let's look at the other one where they now ask me where is it decreasing. So everything just flips. So the top graph is decreasing when x lies between the two turning points, so 2 and 4, and it's decreasing, this bottom one, when x is less than 2, or the other one when x is greater than 4. So you'll notice I never put an including sign when it's talking about increasing and decreasing. Okay, you call A and B a stationary point, so at that point it's not increasing or decreasing, and therefore I never include those values with these types of questions. The next question you will face is, when is something concave up and when is it concave down? Now, that, if you look at the screen, is when the double derivative is positive or negative. So remember, the point of inflection is a point exactly between the two turning points. And with those weird tan-shaped graphs, it is the stationary point. It's the exact middle of the graph. Okay, so it's concave up, left or right of the point of inflection. So it's concave up with the side that has a happy face. So this top one is concave up when x is greater than 3, and the bottom one is concave up when x is smaller than 3, because that's where the happy face parabola is. If you imagine I cut this graph exactly on point C, then the side that has the happy face parabola would be concave up, and the side that has the sad face would be concave down. Another question that's present in almost all exam papers with calculus is this one. They will give you a formula, and this is normally like question 6.5, or it's way down after you found the formula and turning points and everything else. Okay, so the question reads, for which values of k will fx equal to k have 1 root, 2 roots, or 3 roots? This question always has the same answer. The y values of the turning points will just change. But if you study this, then you're going to be safe. Then you're going to be able to answer every question. So if I look at this graph where it is right now, it has two turning points. One is 2 units above the x-axis and one is 2 units below the x-axis. So this graph, if k is 0, has 3 separate x-intercepts. So now there's 3 variations to this question. Let's look at all 3 of them. If they ask me how far must this graph move so that it has one real root, then the answer is always just it needs to move further than the turning point. So it needs to move 2 up or 2 down. So in this example, it is that k is smaller than -2. So that's why the graph is going up, because the k moves to the left of the equal sign. And that's why it moves 2 up. And in this case, it moves further than 2 down. So if k is smaller than -2, or if k is bigger than 2, then the graph will have one real root. The easiest one of the 3 is if they just ask you for 2 roots. So then the answer is always k is equal to the one turning point, or k is equal to the other turning point. So in this case, k is equal to -2, or k is equal to 2 will give me 2 x-intercepts. Lastly, if they ask you for 3 roots, the answer is always k lies between the y value of the 2 turning points. So now that you know the theory behind this, let's answer this actual question and see if it makes sense. They are giving me a formula. They're telling me P and Q are the stationary points. And then they're asking me for which values of K will it have one real root. So if I look at this picture now, it has 2 roots. So it has to move somewhere. Now, if this moves a little bit down, just like 0.1 down, then this would be my only x-intercept. So the answer for question A would be if K is just anything bigger than 0. It can literally be 0.01. But it must just be bigger than 0. Now, why is it a plus if I want this to move down? Because k is on the right-hand side. So any value I put there, let's say I put a 1 there, then if I move it over, it becomes a -1, which pulls this whole graph down. And that's why my one answer would be k must be bigger than 0. So I'm just looking at that value there. Then it also has another part to the same answer, or k must be less than -4. Because this means the graph would move more than 4 up, and then it would also just have one x-intercept because the other turning point would now be above the x-axis. Okay, so those are the 2 answers for question A. Question B, how far must this graph move up to have one positive real root? So then it just means it moved past this point. So if it moves up more than 4 units, so it's the same question as question A, but now they want one positive root. So I can just say this is when k is smaller than -4. Question C is now the opposite again. So this is now only that answer, because it just means if this graph moves a little bit down, then it's only going to have one negative root. Okay, question D is now another variation. Where will it have 2 different roots? So if the graph doesn't move, if it stays exactly where it is now, it has 2 roots. So the one answer is if k is equal to 0, and then the other one is when k is equal to -4. Okay, so just once again, if it has 2 roots, I just look at the y values of my turning points and just say k is equal to them. If it is 1 root, then I just say k is bigger than the bigger one and k is smaller than the smallest one. And now with question E, where it has 3 roots, my answer will always be k lies between the 2 y values. So I'm going to put the -4 there, and I'm going to put the 0 there. So if k lies between that, then it will always have 3 x-intercepts. Okay, guys, make sure you understand this, and then they won't be able to catch you out. There is a question like this in almost every exam. Doesn't count a lot, but if you can get 3 marks, then take it. So one of the questions that scare the most people and that most students that don't like functions leave open is the inequality with graphs question. Please focus now in this section. I'm going to try and explain it as easy as I can, and hopefully you are not one of those numbers and you will get these marks in exams. It looks very daunting and scary, but it's actually just a small recipe you need to know, and if you know it, you can get every mark in this section. Okay, so the questions like this would be something like, where is fx times the derivative of fx smaller than 0, or bigger than 0, or times the x, or something weird that they can concoct, but it will always be these 4 blocks that you see on screen. Now, a question like this is all about that rule you learned in grade 7 with a minus times a minus gives a plus, and a plus times a minus gives a minus. So that's all I'm looking for with these questions. Where is it a plus and where is it a minus? Okay, so let's go through each of these 4 blocks, and then we'll do a question together a little bit later on, and then it will hopefully make sense. Now, if they give you just a normal fx, so this top left block, I am just looking for y values. So where is the y values positive? So obviously everything above the x-axis would make y positive, and everything below the x-axis would make y negative. The block on the top right, where is x positive or negative? Now, it sounds very simple when you look at it now, but in an exam, this is the one that freaks out most people because they don't know what to do with this. It's literally just left of the y-axis, it's a minus, and right of the y-axis, it's a plus. Okay, so don't let them get you with this one. It's just a left or right question. Now, where is the derivative negative or positive? Remember, the derivative represents the gradient. So f prime x is positive when the graph is increasing, like you can see on screen now, and it is negative when the graph is decreasing between the two turning points. Lastly, the double derivative. So that is all about concave up or concave down. So once I know that C is my point of inflection, I can just say, oh, where is the double derivative positive? It's everything bigger than C, because that's where the happy face parabola is. Remember, concave up and down. If I split this graph on the point of inflection, which side is the positive parabola and which side is the negative parabola? That's concave up or concave down. Now, they can mix and match the combinations of these questions, but if you remember that, what does all four of these represent, and where is it a plus or a minus? Then they won't ever be able to catch you out. And so this is what you can expect in an exam. There's just question 5. You'll only see about 2 of those in an exam, never 6. But just for me to explain all of this in one video, I just made it a bit harder than you can expect in an exam. But let's go through it step by step. And then you have something you can refer to always, and make sure that you get your full marks for the calculus section. Question 1, show that A is equal to -4, B is equal to -11, and C is equal to 30. Now, they are referring to this little formula up there. So I need to find the values of A, B, and C. Now, I am going to look at my graph, and I can see x-intercept, 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 and that is enough for me to answer this question. I will then start with y is equal to A, and then x minus x1, x minus x2, and x minus x3, but I'm immediately going to sub in. So it's just x minus minus 3, x minus 2, and then x minus 5. Now, I normally look for another random point, a fourth point that I can sub in. I don't see it in this case. Later on, they ask me what's the coordinates of A and B and C, but I can only do that after I have the equation. So please, guys, like I said in the other video, don't make the same mistakes I did. They are actually giving you the A value. Okay, they're just messing with you by putting another A in there. It's not the same A. So I know the A that I am looking for is 1. So that means I just need to FOIL out and distribute that last bracket in. And once all the brackets are gone and I simplified, that would give me A, B, and C. So let's go for that. So I know this first value is just the 1 because that's what is in front of x cubed. Now I'm going to FOIL the last two brackets, so x plus 3, and that's equal to x squared minus 5x minus 2x plus 10. So now I'm just going to distribute in, so I'm going to multiply all 4 of those with x. So that's x cubed. If I put these together, it's a minus 7. So it's minus 7x squared, and then plus 10x. Now I'm going to multiply everything by 3, so plus 3x squared. Minus 7 times 3 gives me minus 21x, and then plus 30. Final answer is then x cubed minus 4x squared minus 11x plus 30, and that's exactly what they told me I'm going to get. Go and watch the video on how to get the formula of a cubic if this was not clear. Question 2, determine the coordinates of A and B, and I can see it is the turning points of this graph. So I now know the fx formula. Let me now just get the derivative formula. So f prime x would be equal to 3x squared minus 8x minus 11. If I now put that equal to 0, I can solve it. So this would be a 3x. That's just an x. This is a 11. That's a minus. This is a plus. And that's a 1. So therefore, x will be equal to 11 over 3, or x would be equal to minus 1. They are asking me for the coordinates, so therefore I must just get the y values as well, and I'm just going to sub it into my fx formula. You can just use the calculator. You do not need to show them how you subbed it in. They're just interested in the answer. So after I subbed it in the calculator, I got 11 over 3 gave me minus 14.81, and then minus 1 gave me 36. So the coordinates don't look very nice, but that is what they are. Question 3, determine the equation of G. Okay, so they're telling me D is the y-intercept. That means if I make all the x's 0, I can see there's just a 30 that remains. So 0 and 30 is the coordinates of D. And they're also telling me that this graph G is a tangent when it touches at point D. So to find the formula of G, I just need to do my steps to get a tangent. I know that the x is 0 and y is 30, but I need a gradient, and the gradient of the tangent is always connected to the derivative. So in this case, the derivative is 3x squared minus 8x minus 11. To find the gradient of G, I just need to sub in the x value where it is tangent to the graph, and that is point D. So if I make all my x's as 0, I will figure out what m is. So it's 3 times 0 squared minus 8 times 0 minus 11, everything cancels out, and m is just minus 11. So the formula for G would then just be y is equal to minus 11x, and I can actually see the y-intercept, so I can just write plus 30. I cannot go and sub in D into x and y, and then I would just see it's 30 again. So that is the answer of G. Question 4, determine the coordinates of C. That is the point where the tangent cuts the graph again. So this is a bit of a long question, but all I'm going to do is I'm going to do simultaneous equations. So I'm going to make the two graphs equal to each other. So I'm going to say x cubed minus 4x squared minus 11x plus 30, and then that would just be equal to minus 11x plus 30. Okay, now I move everything to the left, and what I'm left with then, luckily, is just x cubed minus 4x squared. The 11x's cancel out, the 30's cancel out, and that's just a 0. Can take out x squared, then what's left is x minus 4 equals to 0. So therefore, x is equal to 0, or x is equal to 4. I really expected something way worse, but that wasn't too bad. Now, they're asking me for the coordinates. I can see when x is 0, y is 30. We established that, but I don't know what it is when x is 4. So I must then just sub that in to any of my formulas. I'm just going to take gx because that's so much easier. So if I sub in a 4 in the place of x, then it's going to be minus 44 plus 30. So y is then equal to minus 14. And therefore, the coordinates of c will be 4 and minus 14. And I can just write na there. So now we get to the inequalities. Determine the values of x for which fx would be less than 0. So like we said in the previous screen, fx is representative of the y values. So they're just asking me, where does this graph go below the x-axis? Where is y negative? And I can see it's less than minus 3. So x is smaller than minus 3. Or x is between 2 and 5. So I'm just going to write x lies between 2 and 5. Now, I'm not including any of them because the question didn't include them. Question B, where is the derivative smaller than 0? Now, remember, we said that is when the graph is decreasing. So I'm looking at my two turning points, and I'm looking at the x value. So I can say it's decreasing when x lies between minus 1 and 11 over 3. I don't need to do anything else. That is what they want. Question 5c now complicates things again, because now they're asking me for the double derivative, and that always has to do with the point of inflection. So I first need to get the derivative and then the double derivative. So the first derivative, as we've seen a few times now, was just 3x squared minus 8x minus 11. And now the double derivative would be 6x minus 8. And if I make that equal to 0, I take the 8 over and divide by 6, then x is equal to 4 over 3. They're not asking me what is the point of inflection, so I don't need to get the y value. I'm just interested in x. So question C, where is the double derivative greater than 0? So where is it positive? Therefore, x is greater than 4 over 3. If they're asking me where is it concave, up. Now with question D, we're getting into the interesting question. So x times the derivative must be smaller than 0. So now we need to really remember what everything stands for. First things first. Am I looking for a plus and a plus or a plus and a minus? So they're asking me where is it smaller than 0? So let me just highlight that for you. Okay, so I am looking for a plus times a minus or a minus times a plus. Let's look at where that would be. So the x represents left and right, and the derivative represents increasing and decreasing. So for the variation of plus minus, I want something to the right where x is a plus, but it needs to be decreasing. So that is then this section here between D and B. And therefore my answer would be x lies between 0 and 11 over 3. So where is it on the right where the graph is decreasing? Or the other variation, when x is a minus, so on the left where the graph is increasing. So then it is from minus infinity all the way to the ax value. So I can just write that as x is smaller than minus 1. For question E, where is fx times the derivative of fx smaller than 0? So because it's smaller than 0, negative, I want a plus and a minus or a minus and a plus. So the first one would be fx, which is a plus above the line, and then the derivative, which is a minus, so decreasing. So I'm looking for a place where the graph is decreasing above the line. And that answer is between A and when x is 2. So I can just write x lies between minus 1, which is the x value of A, and 2. So it's above the line and decreasing, or the other one below the line and increasing. So then I have two values. So x must be smaller than minus 3, or x must be between B and 5. So I'm going to say x lies between 11 over 3 or 5. Okay, guys, I know this is complicated, but I hope it's making a bit more sense than it normally does. At F, where is the derivative times the double derivative? Negative. Okay, so let's go again. Negative means a plus and a minus, or a minus and a plus. Now, derivative means increasing or decreasing, so I want a graph that's increasing. And for the double derivative, that must be negative, so that's concave down. So I am looking for a part that is increasing when the graph is concave down, so it must be less than 4 over 3. So my answer would then just be everything left of A. And I write that as x is smaller than minus 3. The other variation would now be when it is concave up, but decreasing, and that is then from the point of inflection to B. which I would then write as x lies between 4 over 3 and 11 over 3. Okay, so as you can see on screen now. Okay, guys, I know this is tricky, but please go over this slowly again and try and make sense of this. It is marks that many people just throw away in an exam, but there's no reason for you to throw it away. You can actually get these marks and then lift your overall percentage for paper 1. Question 6, for which values of k will fx plus k have one real root? Okay, so now in the previous slide, we explained a bit about these questions, and they are asking me one real root. So there we said when it is smaller than the smallest one and bigger than the biggest one. But now watch out, I specifically put this one in because they catch everyone out with this one. In the previous slide, our question said fx was equal to k. And that's when those answers counted. But if you look at this, they say, oh, no, we're moving the k to this side, but we're making it a plus now, just to confuse you more. So now it is fx plus k is equal to 0. So now whatever you learned in the previous slide, just change the signs. Then you'll get these ones correct. But let's discuss it slowly. For which values of k will this graph have one real root? So immediately, I'm looking at the y values of the turning points. So I know a is at -1 and 36. So that 36 is going to be part of my answer. And b is 11 over 3. Not very interested in that, but minus 14.81 is now the important value there. So for this to have one real root, I want to move this graph up or down past the turning point. So let me just try and make my best version of this graph. Okay, didn't go too bad. Okay, so if I move this graph up more than 14.81, then it will only have one x-intercept, one root. Okay, so I know that's one of my answers. I want k to be bigger than 14.81, or the other variation, I want k to be less than 36. So if this graph moves 36 down, then it only has one root. And that will be my two answers. So let's just see how I would write that. So I want k to be smaller than 36, or k must be greater than 14.81. If those two things happen, then the graph would move past the turning points, and I would only have one root. Question 7 looks extremely complicated, but it really isn't. Let's just go through it. Determine the value of p if that whole thing decreases for the interval x lies between -3 and 1 2/3. Okay, now something you need to remember from grade 11 is if I put a variable in a bracket with x, it's going to move the function left or right. And it's always opposite to the sign. So if it moves right, then p needs to be a minus. And if it moves left, p needs to be a plus. Okay, but what are they now asking me? So if I look at the original function as the picture is drawn there, it is decreasing between a and b. And if I write that in algebra, then it would be it's decreasing from -1 to 11 over 3. Remember, 11 over 3, I can actually rewrite as 3 and 2/3. We just don't really use mixed fractions in the high school because it messes with algebra and it's not nice. So if I now look at the answer that I just wrote in green and where they want me to go, it's actually very simple and everything must just move 2 to the left. Okay, so this needs to become -3 and this needs to become 1 and 2/3. So I'm just subtracting 2 from both, and therefore p must be equal to 2. So like I said, the graph wants me to move the thing to left, and that's always opposite because p is in the bracket, and that's why p needs to have a positive 2 in the bracket. Okay, guys, I know this was probably one of the more complicated videos that we've done. Please go over it slowly and many times until it makes sense. This is going to count a lot of marks in your paper, so please make sure you're not going to get every single question in every paper, but a variation of them will definitely welcome you in prelims or finals. Please try the practice video for graph interpretation. We will also upload a few questions from actual exams to show you exactly how to answer them and how extreme these questions can get. With enough practice, you will be able to get these marks in exams. Just don't give up.
If this video helped you, please like and subscribe.
JMath.